It's been a minute, but we're back. We got a new tool back there. Not Clayton. Clayton's the old tool. But we got a 3-axis CNC mill. This is both very new, or this is new to both Clayton and I, very new. We have spent the last year basically 3D modeling and messing around with 3D printing and stuff like that, kind of in behind the scenes. We got the 3D printers about 6 months ago or something like that. We've done lots with them. I've done some CNC with my plasma, so I have a little bit of an idea of what's going on with it. But we got a 3-axis mill. Clayton filmed a bunch. We have some footage, I guess, when we picked it up, so we'll show you that. We're about to try to do our own first operation with it, but we'll show you when it got here. Oh, by the way, those are nice. Run program. Yeah. Oh, it didn't break.
No. And you can monitor it like this is 10,000 deep under sea. Like I said, you could go 100 times faster than that. It's just gonna leave
100 times?
Oh yeah, I could crank it all the way up.
Yeah.
The
doesn't even think about
the finish is just not the
Yes.
right. Yeah. So you can put it back to
100 is regular speed.
yeah. You can slow it way down. Oh, like I did it, you'll see the difference where I bumped it up and when I took it back down.
Oh yeah, okay. So it just looks the same on both sides.
Yeah.
Okay, let's do that. It doesn't take long, so. Okay, here's what our mission is with this thing. So I'll show you this. So this is the 2.5 turbo setup. It runs now. You'll see that in the next video. Do you think? Yeah, lots been happening. Do you think they miss us, Clayton?
No. Well,
no?
me maybe.
Oh, maybe you. So this was, as you've seen in the video, this was the first thing that we had cut with Dave when he delivered it to test it out. But this is the pulley. This is a DAZA, so RS3 TTRS crank pulley that I want to run on my 2.5. It comes with there was a bit of a edge in here that stepped up, and it had this metal piece in there. Needless to say, this needs to be machined to fit on the 07K. So in order for me to do that, we're going to try to machine this down, but we've never used the mill on our own yet. So we've written a program, and we're just basically going to try to test this out for the first time. So our goals here, we're going to probe the center of the hole and hopefully tell the machine exactly where the fake, because again, that's going to go in there, or in the end, we're going to put this in here to machine the middle of this. So we're going to pretend that that's the hole. We're going to tell the machine where it is, and we're going to try to cut down in a circle without crashing the tool. Guaranteed to break endless end mills trying to learn this, but we're just going to take you along for the ride and show you how much we mess up. How much are we going to mess up, Clayton?
Not feeling super confident. I'm feeling confident that we're gonna mess up.
That's a good answer. Clayton, we're going to wreck some stuff. We gotta do the coolant, remember?
Okay, didn't direct it good enough. Splusion on me. Try that.
Okay, cool. Are your eyes working? Oh, that's a 90. Yes, they are working. If you stand over here, it looks like this just points that way.
It doesn't. It's a 90.
Okay.
Yeah, that's pretty good.
So I don't know, man. Are we wrecking stuff now? Because I'm super nervous.
Okay. Play.
Yeah, we gotta shut the door.
Oh, that's not good. I can't see anything now.
Well, we're guaranteed to break something. Do I just press play?
I don't know.
Well, I'm gonna press play. Here goes. See you later, Endmill. It may be way too fast. That's the other problem. Where's the feeds and speeds? How do I hide all this for now? This is just 100% feed override spindle.
Yeah, you can slow that down.
So
You can slow it down right now if you want
I'm
to.
going to.
Do we know if our emergency button works?
I don't know.
Like you got your thing on the stop there.
Yeah.
Alright.
Technically thought I just pressed start by mistake because this thing is so touchy.
Oh bad.
Oops, I pressed stop by mistake.
Scared.
I get nervous. Where's it going?
I don't know.
Is it spinning the spindle?
Oh, it's facing. Okay.
It's too high though, right?
Which is fine.
This couldn't. That's a perfect scenario here. Because the stock that we put in was too small for what we were doing. Okay, we did something. Hasn't failed yet.
Yeah.
It's way high. So that's okay because we're going to change the Z. Right?
Yeah.
We'll change that offset.
You could probably up your. Oh, you're 100% right now.
No, I went back because I stopped it. Oh yeah, we didn't fix the leak.
Okay, well, we're gonna stop just for a second because nothing's really going on. I'll start filming when
We get some action.
when something happens. All right, well, it didn't wreck yet. Did nothing actually. I don't know where Dave went. He's looking for something for this drift because he's all upset that that's drifting. So we did a recalibration of some sorts, and now we're gonna wreck it.
I don't know, man. I don't feel safe. I'm gonna put goggles.
Goggles? We're
Yeah.
behind 2
I don't
layers.
care. I don't care. You can lose your eyes. I'm not. Just gonna crash.
Wait,
Still not low enough.
I don't think it can go anywhere yet.
Still not low enough. It's doing the exact same thing.
Is it?
I think so. Yeah, it looks way high.
So we still don't know what we're doing.
Why is that doing that, Clayton?
I don't
Is
know.
this bucket even in the right spot?
We did the probe. We did the probe to the piece. Then we changed out the mill, the end mill, and did that to the setter, and that should be it.
Yeah, it's something. I mean, it could be in the program though, Marty. I feel like it should be taking off something. Well, it's not even getting to 0. This is how you wreck stuff. Are you ready?
Mm-hmm.
What do you say? Hold my beer.
Oh yeah.
Oh, I can't do anything. Doesn't let me do that. You have to do that beforehand. I feel like it's this. So how far down do we want it to go?
Oh, the 10 thou, numbers. Machinist lingo. He went like, oh, tabernacle.
Yeah, we
hit one of those buttons.
Yeah. I don't know, Clayton. I don't know. Just nervous. How do we get that down there? Oh my god, it touched.
Yeah, because it's below your 0.
Yeah, but why wasn't it doing it before? I think it has something to do with the program. I mean, could we cut any less?
I think you'd speed this up. We're on full chooch. So that worked for what we wanted, so we're gonna try the next.
Well, it sort of worked. It didn't really do what I wanted it to do.
Well, whatever.
So this may also wreck some stuff. So I'm gonna feel like it's not gonna cut anything, and then it's eventually gonna cut, but it's gonna not do what we want because it doesn't know the right Z.
Yeah, yeah.
It's gonna, because we're trying to dig a hole, it's gonna eventually start digging a hole, but way too late.
Yeah. So it's not gonna go deep enough at all.
Right.
Yeah. Okay.
Yeah. So that's we have a problem with Z.
Yeah, we hidden. Now, would that be in like the tool setter, like the calibration, or?
Man, I don't know.
Yeah, just let it go.
No, I don't think I want to. I'd like to. It'd be nice to get it to start from the top, because then we can know that it's gonna cut.
Well, look, it's not even to Z0 yet.
I get it, but it should be cutting. Is what I'm saying. It should know where that piece is.
Yeah. Why is it starting at Z0 though, or Z.24? That's exactly what it's up. It's up
0.25 of an inch.
Yeah. Quarter inch.
Yeah, I don't know why. That's what I'm saying. I don't know why. Go get your beer. Clayton's gone to get beer. I'm sure this will all make sense later on, but it probably has something to do with my tool paths and the piece of stock. So we're starting this a little bit weird because, again, if I was just cutting a piece of raw material, I would have put in the machine where this is, and then when you load the program, it will start cutting because it knows the piece of the stock based on the software. But because I'm trying to pretend that that square piece is essentially this whole thing, because in the program this is drawn up and I'm trying to cut the center out. So I think that's part of the confusion, is that this, I mean, technically this is thinner than what that piece of stock is. So very confused. Again, I'm sure as time goes on, as I figure it out, it'll all make way more sense. But we had one trial run showing us how to use it, and that's where all these chips are from cutting that first piece that we did. We did both sides just to test it out, and it worked great. However, trying to do all of this from scratch, and we learned, turn this around, the machine landed here like, I don't know, a month ago, and I've been super busy and lost my voice, and it's been very hectic here, so we haven't even touched this thing, aside from mounting the screen on the wall and stuff like that. We haven't turned it on, nothing. So this is basically the very first time of us trying to use this with some program that I created, barely knowing what I'm doing. So we're learning. We're going to get back to trying to cut some more. See if we can at least cut a little bit of a hole in this thing.
Okay.
I don't know what it's doing. Doesn't make sense.
See, it started the operation. Look how high it started the operation off the thing. Alright, so it did. It did a thing. Here, I'll put that here.
It did do a thing. The question is, did it do it deep enough? That's what she said.
It's muggy in there.
Yeah, it really is. So, I mean, it's a success where we didn't really crash it. I did drive the end mill into the piece at one point because I got a little overzealous with my rapid moving in the steps or whatever. However, is it proper depth, Clayton?
Well,
we don't know. We'll measure it.
We can check it right now.
And we did just go look at the tool paths and stuff. There was a couple things this thing that's coming up here, that looks like I had that all in the tool paths, obviously, because it's in here. I don't know why. But we're just not sure why. Yeah, we're definitely learning. We're not sure why the 0 isn't 0. Who knows? We're gonna measure and see how close we were. So we want to measure off of this,
this
to there.
to there, and if this to there is deeper, which I can already tell it is.
You think that's deep?
Oh yeah.
This is deeper?
Totally, we did it.
No, we didn't.
Yes, we did. Conclusion.
Well, we hope to make some parts for you guys. That's one conclusion. But we honestly have no idea what we're doing.
No, for this.
We have, how many percent?
Oh my god. What?
How many percent do we know what we're doing?
Right now it feels like maybe 5. 10 I'd say.
Okay, I'm with you. 10%.
I think the design we're super comfortable with. Like I'd say 100 right now.
Definitely not 100.
100. We'll call it 100.
Okay, sure.
100 of what
On
we'll
our
ever have to
scale.
do. I think the functions of like the tool paths and stuff like that, I'm a 0. I
Yep.
think yours might be like a 20.
Well, I got us here.
Maybe 30%. 40, I'd say.
Okay.
Yeah.
So, yeah, there's definitely a lot more learning to do with it, but we did.
So what happened? So what happened here? We think that the machine was starting up too high.
Oh, well, we didn't show the measurements.
Right.
So I measured. The idea was to just cut to this surface, so that we're pretending that we're cutting
Making
this right. So we wanted to cut down this deep. In this hole, it is not that deep, but as you guys probably seen at the beginning, it was trying to cut way up here. So it's thinking the stock is way up here. So the hole would have been the right depth. The only reason it faced it down here is because I forced the Z height to go down because I wanted to see it cut.
Oh, and this makes sense. And that was only for the facing operation.
Right.
So we didn't zero it
Exactly.
for that operation.
Exactly.
We're on the same page.
Exactly. Yeah. So I just don't understand why it's trying to cut way up here. I'm gonna figure that out. But we didn't break any end mills.
Well, and what they didn't see is like we tried, like we put the probe in, did the probe to this, the probe to that, blah blah blah.
Yeah.
Put the tool in. Sorry, couldn't see it there.
Yeah, let me
and
move
did
that.
the probe onto that. So I mean, it should have, or not the probe, the tool setter or whatever. And yeah, anyway, I don't know. Crush it into that now.
Yeah. So we have a probe that we probed. We put this in here. We probe the piece on the tool setter.
The probe to that.
Probe to that, then the probe to this, so it knows where the piece of stock is in the machine. Then we put the tool in and we set the tool. So the machine knows where the tool is, and the machine knows where the piece of stock is.
So ideally, it should have did the calculation of the probe, because it knows where the probe was in that, and knew where the probe was to this. Then we did the probe to this. So really, when we put the tool into this, it should have figured out the distance.
It should have.
It should have.
But for some reason, it did not do that. And again,
and you know what? Probably because
we're learning.
What I
because
just
we're
said
idiots.
is like the wrong thing to do and the wrong way to do it.
But we didn't crash it, which is a huge thing because smashing end mills, it's going to happen. We're going to do it. But for the very first time, not to slam an end mill into the piece. So that's success. I don't think I mentioned this at the beginning of the video. This came from our buddy Dave that does KDN shifters. So I'll probably get Clayton to add in a bunch of footage of this machine actually running parts and making cool shifter parts. He's upgraded to a Haas. Maybe someday that'll happen with us. But at this point, we barely know how to work a printer. So to try to get this to work, we got a lot to learn.
And maybe we could have our own F1 team, like Langmuir F1.
Yeah, cool. Yeah, that's unlikely also. So, Clayton, we got a lot of homework to do. I don't know what you're going to do, but I need to figure out how to do the tool paths. That is its own entity. And luckily for the CNC plasma table, I've dabbled in it, but I got a lot more work to do.
I'll watch some videos.
Yeah, there's lots of stuff on the interwebs. So I got a bunch of cool part ideas to do. We talked about before Actually pause for a second, Clayton. Obviously way back when I designed this valve cover for my 16 valve, you could see that I already had this in the works. So that's why we tried to get into the 3D printing and modeling so we could design this. So the plans are to make this valve cover, once I fix the mess ups in it, out of aluminum. I'm going to make my own billet valve cover here. But we got a lot of things.
$15,000
Yeah.
valve cover.
Excuse me. Yeah. There's a lot to figure out before we get to that point. But I have a bunch of other cool little parts that we plan on running before we get into doing something like that at that level. But that's a video for you guys. Hopefully you enjoyed. We got a lot of learning to do with this thing. I'm sure there's going to be some machinists down in there that have watched this video that are just cringing watching us try to figure this out. But it is a big learning step. Clayton and I do not have any background in CNC machining at all. So this is all self-taught. So it just goes to show that anybody can do it if you, well, spend a bunch of money for one and a whole bunch of time trying to figure it out. So Clayton, do you have anything to add?
If you got a lot of money and a lot of time, you can do anything you want.
Yeah, the problem is we don't have the time. So that's why this has been sitting for so long before we even got a chance to even try it out on our own. But it's springtime and that's what it is. Hence why the lack of the video content. But we've got lots of stuff coming. My 2.5 runs. You're going to see that very soon. And drag car we had on the dyno again the other day. Still working through some kinks. But it's time to go racing. So thanks everybody for watching. Don't forget to like and subscribe. See you in the next video. Well, that didn't take long. See you later, probe. Looks like I figured it out. Making a mess. Okay, after a bunch of messing around, I think I have it. This, I haven't measured it yet, but this should match what I have in the program, which is about 15 millimeters deep. So, and there was a little bit left for cutting or for cleanup, so I got it. So the problems were a couple of settings in the G code when I created the code to cut it. And then the way we were setting up the tool setter and probing and all that, we were doing that wrong also. So it didn't have the proper Z height. So there's a couple things that made it happen the way it did, but I'm semi-confident on how this has turned out now. The software, you can see I touched down on that to redo Z axis to cut this second hole. I don't know why it needed to do that. That's stuff I gotta figure out still, but once I redid Z, I know this is gonna be foreign to a lot of people that are watching this channel, but we're getting somewhere. So there it is. First cut, first operation, finally to the point where it's supposed to be. Well, I haven't been at this too long trying to figure this out. I've already had my first casualty. I broke the probe. Luckily we got some spares, but lesson learned, I'm guaranteed to break so much stuff doing this, but one click of this arrow instead of this arrow and just said snap because it was down inside a hole. Anyways, we're figuring this out.